Hopefully everybody got a chance to get something to eat. So it's late, it's getting darker, your stomachs are full, and we're going to talk about a nice light topic like Size and Exchange 2013. So I fully expect half of you to fall asleep at least, maybe more. I know it's been a really long day. So thank you for coming. It's a pleasure to be here. For those of you who don't know me, my name is Scott Schnall. I'm a technical writer on the Exchange team. And I'm really excited to be talking about Sizing Exchange 2013 because we haven't really had a chance to talk about that a lot with customers. We have done a lot of work on our blog and in TechNet, and we have presented some information at some events like TechEd, but we haven't really done a full sizing session like we're about to do here at TechEd Australia. So just a quick poll. How many of you are running 2010 today? How many of you are on 2007? Has anybody yet deployed 2013 in production? All right. Anybody about to deploy 2013 and you're here because you need to know how to size it? Awesome, great. Okay, well, obviously this is a session all about sizing, so we'll go through a sizing overview. I'll walk you through the kind of data that you need, the tools that we have, the process that's involved, and so forth. We will talk about some of the changes in Exchange because the architectural changes in particular do very much impact the way you'll size Exchange. So although the tools will be similar to what you may have used in the past, the architectural changes really change some of the performance footprints of a lot of the components and the server roles. We'll also talk about our server role requirements calculator, and I'll do a little demo at the end. And then I'll mention some other tools and resources that we have that you'll want to be using for your sizing exercises as well. So let's basically start with the sizing overview. I'm going to walk you through what the process is from an Exchange perspective, but I also want to start out with a little bit of history as well. Obviously, Exchange 2013 is the successor to a long line of Exchange versions. And so what that means is that the Exchange product group in particular has been doing a lot of performance analysis and sizing exercises for a really long time. And in fact, in some cases, we've had some of the same performance PMs doing that over multiple versions and, of course, multiple years as well. So we have a lot of experience under our belt, but of course the experience can only take us so far. We still need to collect data from deployments, and obviously we need to account for the architectural changes. But we're pretty good at this by now. We've been doing this for a long time, and we've really got a handle on how to gauge the kind of recommendations that we need to give to customers. Now, historically, the sizing guidance that we... Pardon me? You're having trouble hearing me? Is anybody else having trouble hearing me? Yeah, a few people. Can we raise the level a little bit? Maybe I'll move this up a bit. How's that? Is that better? Any better? Okay. So the sizing guidance historically that we've gotten has come from pre-release deployments in a lot of cases. So that could be our own internal dog food environments where both the Exchange team and people outside the Exchange team are using pre-release versions of Exchange before we ship it to customers, and we're actually exercising the code that way in our own production environments. So they're not test mailboxes that we use. We use our own actual corporate mailboxes in these dog food environments. And we also get a lot of valuable information from the MSIT deployments as well, although typically that sizing guidance comes after we've released the product because that's typically when MSIT finishes their deployments. And of course, we've gotten information and data that we've gathered from the field and from customers who've shared data with us, particularly large-scale customers as well. Now, one of the things that we're going to talk about is our storage guidance, and that refers to the disk IOPS. We have done a lot of work in Exchange 2013 to continue the work that we started in 2007 and carried through to 2010 to reduce disk IOPS. And I'll talk about the reduction that we've achieved later on. But there is a nice reduction in IOPS that we have again. That affects obviously both the mailbox databases and your transport queues, which are also backed by ESC databases as well. And our relentless focus on disk IOPS really means that we are actually experts at measuring this and analyzing this, and more importantly, making code changes inside the product to help us target lower IOP drives. In fact, we made, not just in 2013, but in 2007 and 2010, we made some very significant architectural changes so that we could target these larger, slower performing disks. And that in turn has the benefit of reducing the total cost of ownership, because now you can buy less expensive disks, commodity hardware, and not spend a ton of money on the storage subsystem like you may have done with Exchange 2003 and earlier versions. So, data. We use data constantly, obviously, for a lot of the sizing that we do and a lot of the planning that we do and some of the code changes that we'll make late in the development cycle. That is all data that we'll gather as we're doing our daily performance tests, as we're looking at our dog food environment, and as we're doing other things to get the product ready for release. Now, one of the interesting things about data is that when you think about the data that's collected both from a sizing and troubleshooting perspective, it's really, in a lot of the cases, it's really after the fact that a lot of this data gets collected and then it gets analyzed and we can act on it. So we actually made a fairly significant change in Exchange 2013. We had this new service called the Exchange Diagnostic Service, or EDS. And EDS basically is there to gather primarily performance data through built-in performance data collection sets that we've created and programmed EDS to go ahead and collect on a periodic basis. And so what that means is that because the data is always being collected at runtime, if there is a performance bottleneck or if there is something that you need to troubleshoot around sizing or performance or capacity planning, you don't have to reproduce the issue because the data is being gathered all along. So we use that data extensively, particularly on support calls. We'll have the customers gather it from the file system on the Exchange server and send it in to us for analysis. And we do the same thing in Office 365 as well. We can collect all this data from the servers in real time and put it into some sort of big data store and do analysis on how we're doing with the product and find places where we're not as optimal as we could be with respect to performance, and we'll make changes as a result of that. Now, obviously, the data is there for us to use, but it's also there for you to use if you're interested in looking at it as well. So it's in the file system. We do all of our diagnostic and other logging now happens in the same basic install path where you deploy Exchange. And I'll talk about the impact of that vis-a-vis capacity planning in a little bit. But you can see the path here, this Exchange server /v15/logging/diagnostics/daily performance logs. That's where they're all located, and you'll see this series of performance monitor files. So you can just go ahead and open those up in perfmon, view the data that's been collected, gives you great historical information about what's been going on. So if you're troubleshooting some sort of client activity issue, or if you're looking at something like workload management is throttling user activity because of resource load, all of the information that you need to troubleshoot that problem will be in these diagnostic logs. So make good use of them because that's what they're there for. Now, when we talk about the sizing guidance and we go through the sizing process that we're going to go through in a bit, it's important to keep in mind that our guidance doesn't cover everything. And there's a really simple reason for that, and that is we can't cover everything. I mean, there's certainly cases we simply have no visibility into, and we have no way of telling you what the performance impact will be. So, for instance, we're really just limited to the deployment models that we use. And I mentioned we've got several. We've got our dog food deployment forest. We have our MSIT forest. There's another development forest. And, of course, we've got all variants of online Exchange services ranging from the BPOS to there's still some Live at EDU out there. And, of course, Exchange Online and Office 365. But that's really the majority of where we get our data from. So we don't cover everything. And of course, we don't cover all client versions as well. And when you talk about data that we're gathering from MSIT or our own dog food environments, when we dog food new software, we're typically not just dog fooding one product in isolation. We're very often dog fooding multiple products at the same time. For instance, the version of Windows we're about to release, and the version of Office we're about to release, and the version of Exchange we're about to release. So we typically are covering the latest and greatest operating systems and the latest and greatest clients as well. But of course, out there in the real world, you have a variety of clients out there, and so that needs to be taken into account. But there's simply no way for us to test every client in every scenario, so we are somewhat limited in our ability to give you guidance there. And of course, generally, third-party solutions are not included. Every once in a while, a third-party solution will make its way in because it becomes integral to the deployment itself. So when you think about 2010 or 2013, maybe think about load balancers or hypervisors or things like that, other non-exchange products that might come into the mix and have a performance impact on our sizing guidance. And of course, line of business applications, most of which are going to be custom and unique in your own environments. There's simply no way we can test those and tell you what the performance impact of those applications or that integration or the client traffic will be from those applications. And of course, there's all sorts of variations in hardware, although we're much better at identifying the hardware that we use for the data testing that we have and in the server role calculator that we have. And then, of course, there's other things as well, ongoing product usage. As we make changes to the product through cumulative updates, we can't possibly go back and retest everything and gather all new data. So we don't very often update our sizing guidance with updates as we roll them out. However, in the cases where we do make significant changes, we may go ahead and alter our guidance accordingly to account for those changes. And of course, in those cases, we do get the data from our daily test and from our deployment into the cloud first as well. And then, of course, there's some features that we just don't light up to do all the testing. I mean, there's a lot of different features and, of course, integration into Link and into SharePoint and so forth, and we just simply don't have the ability to test every combination of every features. So typically what we'll do is obviously we'll do a lot of testing of all the core features. How does content index working? How is mail flow working? How is client access working? How's RPC activity and so forth? So we do cover a fair amount, but again, it's simply just impossible for us to cover everything. So generally, in cases where we know there are going to be gaps, and we still want to try to give you some guidance, what we will do is we will just be very conservative. In fact, given a choice between being conservative and not, we will always be the more conservative guidance for you. We would much rather have a customer potentially over-deploy or deploy more hardware than perhaps might be necessary for their deployment than we would want a customer to under-deploy. Under-deploy is a bad client experience. We wouldn't want anybody to do that. All right, so sizing without guidance and tools. Now, generally, I normally wouldn't even be talking about this because we do have our most popular sizing tools out, the server role requirements calculator and our jet stress tool, which I'll talk about in a little bit as well. And there are other tools coming as well. And of course, we now have the guidance in TechNet. But let's just say you wanted to do sizing without all those tools and stuff. You do have some options available. Lab testing is certainly an option, although not all customers have the ability to completely create a lab that mirrors their production environment. Some do. Some actually do that on purpose because they have the ability to do that, and that is just the norm for their company. But not all companies have that ability to do that. So typically what we would recommend, if you just got to do a shotgun deployment, maybe you've already bought the hardware, so your sizing exercise is moot and you just got to get things rolling, then we would want you to go very slowly and do something like start with a pilot, keep it to a small number of users. Try to minimize the over-deployment on the pilot, whereas you're going to be over-deploying perhaps the whole infrastructure once you move beyond the pilot stage. But you still need to do a proper sizing exercise that meets your business requirements around things like availability, particularly high availability, and also around things like load balancing, around client access, and so forth. And then, of course, you're going to be monitoring. You're going to monitor the solution to make sure that the performance counters are looking good at peak times and perhaps at the highest concurrency levels, and you're going to adjust as necessary. Now, hopefully most of you are not going to go down that process of sizing without using our guidance and without using our tools. It is possible, but we typically wouldn't recommend that. What we would recommend is following our process start to finish, and where appropriate along that process, using the right tools to do the job. So the first thing that you want to do is you want to go out to TechEd and you want to read our documentation. And you're also going to want to go to our Exchange team blog. And you're going to want to read some of the performance and scalability related posts that we've published. And those posts in particular are actually done by the performance PM, who's been doing this for many years in Exchange and is pretty much the expert for Exchange performance. And in fact, it's the PM, it's him who is responsible for taking observations from Office 365 and other large-scale deployments and expressing those as our guidance on TechNet for you to use. The next thing that you need to do is you need to gather data. And it's very simple data, and if you've already gone through an Exchange deployment and you've done a sizing exercise, it's the same data that you would gather historically. So we're looking at user activity to determine the user profile. So this would be the number of messages sent and received by that user each day. And of course, you also need to know the average message size of those messages as well. Now, average message size is particularly important from a transport perspective because the size of the message will directly relate to how fast the transport queues can process and deliver those messages. I'll give you some statistics later about what we see in our own production environment in terms of message size versus IOPS that will give you a good gauge as to how your environment will behave as well. So you need to have that average message size. It's very important that you have that. And then, of course, there's all these other business requirements that have to be accounted for as well. And these are going to be unique generally in every environment. Every environment's going to be different. Every environment, for example, will use a different number of database copies. Every environment will have a different backup scheme. Some will back up regularly, some will back up weekly, some will not back up at all and leverage Exchange native data protection. It's going to be different for each customer. There's also some architectural changes that change some of those extra requirements. For instance, we've introduced a feature in Exchange 2013 called Safety Net. Safety Net replaces the transport dumpster in Exchange 2010. Every message that is sent by default through an Exchange 2013 server is automatically saved in transport in a special queue called Safety Net for, by default, 2 days, but you can change that to whatever value that you want. Obviously, if you're retaining these messages longer in this Safety Net queue, then you're going to be having a much greater impact in terms of your sizing exercise. So Safety Net is a great feature, but you're going to need to account for it in terms of your sizing. It's basically there so if you do have a lossy failover in a database availability group, or if you're restoring a database from backup and you're missing messages for that database and you want to get them back, that's how we get the messages back from Safety Net. There's also other things to consider. Maybe you're virtualizing. In that case, there's going to be some overhead and some other things that you need to account for. And by the way, for those of you interested in virtualizing, I would strongly recommend going to see Sandy Miller's session on virtualizing Exchange 2013 this week as well, because you'll learn some of the nuances around what it takes to virtualize Exchange 2013 as well. There's also growth plans to consider. Your company may be static today, but who knows? You might go out and buy, say, for instance, a large phone manufacturer's business one day, and now you've got 32,000 new employees who suddenly need email. It happens. It happens. And you need to consider that. And what's interesting about that is oftentimes the IT folks are not in on those kinds of discussions, and they have no idea that this kind of thing is coming. And so when it does happen, now all of a sudden they have to scramble to get this extra capacity or possibly to merge systems into one and so forth. So there's all these other things to consider as well. And then, as I mentioned, because we can't include line of business or third-party applications, you'll need to sort of figure out on your own what the impact of those applications will be. Now, if you're buying an application from a third-party vendor and they've been doing Exchange integration for a while, they'll probably have a pretty good idea on what the performance impact for that application will be. So you should be able to get some guidance from them. If it's your own internal line of business application, well, you're going to have to do some testing. You're going to have to do some monitoring. You probably want to get the developers of that application involved just to make sure that performance is where it needs to be and so forth. So yes, you want to primarily focus on the user activity, but don't forget all the other stuff that surrounds your Exchange servers and integrates or interacts with them in some respect. Once you have that data, in particular the user profile data, that's when you plug it into our server role requirements calculator, and I'll show you how to do that later on. And once it's in the calculator basically takes it from there. The calculator just does it. You fill in some variables, you choose from some drop-downs, and the calculator just does everything else from there. And in fact, the calculator, as you'll see later on in the new version, has much more functionality in it than it did before. And that's one of the reasons we changed the name from the mailbox server role to just the server role requirements calculator. Now, some of the other things that you need to do is you also need to consider all the other things that might happen in your Exchange environment. So for instance, database reseeds. How many of you are looking at using database availability groups? Okay, and how many of you are planning on deploying those on JBOD without RAID? All right, a few hands went up. So if that applies to you, typically that means you're going to have to end up doing some reseeds and some rebuilds of your servers from time to time. Disks fail, servers fail, that happens all the time. That's why we deploy a DAG to mitigate those kinds of things. But you still need to account for that in your sizing exercises because you really need to size for peak concurrency in your worst case failure scenario. What's your worst case failure scenario? That's going to be up to you. It's going to be driven by your business requirements, and it's going to be whatever number of failures you decide your business needs to survive and still keep the solution up and running. That will also be unique on a per organization basis as well. And then the last thing you do is you'll finalize the design. One of the new things that we've done with the server role calculator is it now actually has these scripts that it can generate for you. And these scripts can actually do things like build your DAG using PowerShell. It can also go ahead and deploy your databases using PowerShell based on the output of the calculator and basically set everything up for you. And what's handy about that is because it's all in an Excel spreadsheet, all you need to do is ferret that away and you've got your change management and your original baseline configuration that you can refer to later on if you need to recover or rebuild or do something else with that server. All right, let's talk a little bit about the changes in Exchange, particularly the ones that affect sizing. So yes, here is that slide. How many of you have seen a picture of this architectural diagram before, or some variant of it? Because we've been showing this for like 2 years now, so I feel really bad every time I bring it up on a slide because I think everybody's just seen it to death by this time. But judging from the photos, maybe not. Maybe it's all new to some of you. But basically, this is just showing the architectural changes. The big ones really to call out is now we're just down to 2 server roles, client access server and the mailbox server. All the other server roles, the legacy CAS, the legacy hub, the legacy they're all in the mailbox role now. And the CAS itself is a new role, basically, that has different functionality from the CAS in previous version. So some of the more important things to consider here is that when you think about the new mailbox role in Exchange 2013, it's really very similar to the Exchange 2010 multi-role. Perhaps the one difference being that when we think about 2010 multi-role, we think about CAS, hub, and mailbox. But here in 2013, we've actually got CAS, hub, mailbox, and all in the same server role. So it is very similar to a multi-role. CAS is different. That's now basically a thin, stateless, protocol proxy, if you will. CAS really itself just has 3 components on it. A protocol proxy for HTTP, POP, and IMAP. We call that component the CAFE, the client access front end. So if you see references to CAFE in the Exchange code, that's what that means. We also have our front-end transport service, which is nothing more than an SMTP, a full application session SMTP proxy. And then the third component is a call router. That's all CAS does. It has no other functions in life. So that means the workload that CAS is doing now in 2013 is significantly lighter than the workload being done in the 2010 and 2007 CAS. Now, of course, that workload still exists. It's now just all on the mailbox role now. The other thing to think of is now that we're down to just the 2 roles, that really just leaves you with really 3 types of server roles to have to size for. One being CAS, the second being mailbox, and the third being Active Directory. Even though that's not an Exchange role, it's still a role, a server role that you need to size for in an Exchange environment. And we'll talk about that in a minute. Now let's talk about some minimum requirements. You may have noticed that the minimum requirements for Exchange 2013 have changed. And in fact, not just the minimum requirements, the actual amount of memory you'll end up putting in your production servers will be significantly higher than it was in previous versions of Exchange. We have added a lot of new technology, including new technology that is particularly memory hungry. And so there are the needs for much higher memory footprints. Now, the minimum requirements we like to publish because we need customers to understand what is the least amount of memory that can actually go into an Exchange server and have it still function. Now, for a multi-role, so Mailbox and CAS, it used to be I could do a full demo with a multi-role machine in Exchange 2010 with just 2 gigs of memory. Yes, it was slow, and if I wanted to make it a little faster, I could make my demo machines have 4 gigs, and I would get a very snappy experience out of it. Now, if I got Mailbox and CAS on the same box and I want to build a lab or do a demo, I really need a minimum of about 8 gigs to get that same snappy experience. I could do it with 4, but it'll be super slow. I could try it with 2, but it would be extremely painful. I don't know if any of you have ever done that yet in a virtualized environment, but you really need to give Exchange much more memory than we had before. The other thing is we also need a lot more disk space than we needed before. We really only needed just a couple gigabyte with Exchange 2010. But in Exchange 2013, in addition to that performance diagnostic logging that EDS is doing, where I showed you that directory, there's also all this other component logging that is turned on, some of which can't be turned off, and it's just all there constantly doing logging into different subdirectories under your Exchange install path. So as a result, our minimum disk space is now 30 gigabytes to deploy Exchange. Now, for a lot of customers, that's not going to be a huge problem, but there are some customers that have unique disk footprints, boot from SAN, those kinds of things, where this could be an issue for them, so they may have to use an alternate install path for Exchange to account for the needed disk space. This is just the minimum requirement. There's really no way to get around these. So the new mailbox role, that changes the sizing exercise quite a bit because, again, it's not just the typical mailbox services where you're thinking about the store and content indexing and maybe some applications that are integrated with it. No, it's so much more. Mailbox has not just all the technologies from the other legacy servers, again, CAS, Hub, and but it also has all these new technologies that we've added to it as well. Now, some of the changes make things easier. Obviously, the fact that we're down to just 2 server roles means that the deployment process has actually been simplified over previous versions. And as a result of making some of the changes, we're also able to realize some pretty good database cache efficiencies out of the 2013 mailbox server as well. And really, our goal in doing that and in doing a lot of work to reduce IOPS, as I mentioned earlier, our goal is really to make sure that customers who size Exchange appropriately can fully leverage their investment in hardware. So what we mean by that is if you properly size your servers, you will be fully leveraging the hardware that you bought. You won't be leaving extra memory or extra CPU on the table unless that's something that you want to do for growth purposes or for some other reason. But our goal with Exchange is to have really strong hardware efficiency while at the same time we made other architectural changes to introduce failure isolation as well. So there are some considerations that you need to realize with the new mailbox role. There are some trade-offs, obviously, in taking the legacy CAS and legacy Hub and blending them into mailbox. That is going to be an increased amount of disk I/O, and that is going to be an increased amount of CPU and memory activity as well. A couple trade-offs there, but not a big deal and not entirely unexpected. We did, though, change our database cache algorithm. So how many of you are familiar with the dynamic buffer algorithm that we had in previous versions? Now, what's interesting is when I ask this question, like only 1 hand goes up or 2 hands go up, but watch this. How many of you are familiar with, hey, the store is taking all available memory? There you go. That's right. You all know about the dynamic buffer algorithm. That's what caused store to take all available memory. Store, as it was running, would calculate how much available memory was available, and if there was memory that it needed, it would take it all for itself. We don't have that algorithm anymore in the mailbox role. We removed it, and in doing so, that made cache management a lot simpler from a code perspective. In fact, we literally cut out hundreds of thousands of lines of code in getting rid of that algorithm. But it also means that we no longer dynamically adjust the cache. Okay, so the cache is always statically calculated now on store startup. So when the store starts up, you have a fixed amount of memory that is automatically assigned to each active and passive database on the server. And what that means, though, from an admin perspective, is if you are adding databases, removing databases, or adding or removing database copies, you'll actually need to restart the store service so that it can statically recalculate the cache. And you'll actually see a little pop-up in the Exchange Admin Center, or you'll get a little message in PowerShell when you do those activities that reminds you that you need to start the store now to recalculate the cache. There's also, because everything is located on one server, and because CAS is basically just proxying to that one server, everything on that server is now interacting. Okay, that's different from what we had before, even with 2010 multi-role. And this interaction is mediated by a feature called workload management that we introduced that is basically there to make sure that whatever's going on the box, whether it's user activity or background processing or some of our system agents or whatever's running, is not impacting the overall user experience. So workload management is there to make sure that if something is starting to use a lot of resources, but there's a heavy user population, workload management can throttle back those system processes and allow the resources to be freed up for user activity. So that's a good thing. Now, we've also introduced some new technology called managed availability. How many of you have heard of that? Okay, just a couple hands. So managed availability is high availability outside the DAG and outside the continuous replication pipeline that basically gives you user-oriented self-recovery capabilities built in natively to Exchange. So as an example, a service that should be running is not running. Managed availability will start that service. Managed availability can't start the service. It will initiate another recovery mechanism like a database or server failover. Or managed availability detects that some process keeps crashing. And after it reaches a certain threshold, managed availability has the capability of taking that server out of production and failing over and so forth. So there's many, many examples I could give you of what managed availability is doing. What you need to know, though, is that managed availability runs on both roles. It's on by default at all times. And literally every second, it is tracking hundreds of different components across all of the Exchange components. So OA, EAS, PowerShell, performance counters, Active Directory, the network, DNS, search, any component in Exchange, anything that works inside of Exchange, managed availability is monitoring it for the user experience and taking self-recovery actions if needed. We've also introduced new content indexing. We've gotten rid of Microsoft Search, and now we use what we call Search Foundation. Search Foundation used to be known as Fast Technology. That was a company out of Norway that we purchased back in 2008. And in fact, our Fast team is still in Norway, so we kept the same development group. But Fast, or Search Foundation, is the single search engine that we now use across Office. So it's in Exchange 2013, it's in SharePoint 2013, and there's also a federated search API between SharePoint and Exchange. So if you're doing e-discovery from SharePoint, you don't have to re-index things. SharePoint can reach into the Exchange catalog and get you the results that way. But that, of course, has a performance impact as well. And then, unlike the traditional Exchange 2010 multi-role, in 2013, multi-role also includes unified messaging as well. So is enabled on all your mailbox servers, whether you're actually using that feature or not. And you could go and turn a couple things off or not, but it's really, if you're not using it, it's really got a negligible footprint. But it is there on all mailbox servers at all times. So let's talk about some storage capacity requirements. Typically, what we want you to do with storage is when you're talking about it from a capacity standpoint, we want you to size for, obviously, whatever the mailbox size is going to be on disk, plus the content index, plus your log space as well. Now, historically, we used to have you add this overhead as well. 20% overhead for the database volume, 20% overhead on the log volume, and so forth. That overhead now is gone. What we used to say is 20% is now 0% overhead. So that does trim off some of the sizing exercises that you would have to do. However, one other change around content indexing is that the index is now much, much larger. Now it's around 20% of the database size. In Exchange 2010 and earlier, it was anywhere from 5 to 10, maybe upwards of 15 in very large environments. But now it's about 20% of the database size. But you also need additional space to do what we call a master merge of the indexes as well. And this is basically taking two sets of large data and putting them into one larger set and then removing the two sets, but you need the free disk space to do that. Now, we do have an interesting new feature in 2013 called multiple databases per volume. And it's what it sounds like. It's multiple databases running on the same single JBOD volume. So non-rated, 4 databases maybe with their logs and separate folders, but all on the same single disk. You do get this benefit if you are using multiple databases per volume. You do get a benefit of fewer master merges occurring on the system. So you will actually have lower overhead in that configuration than you would in a single database per volume configuration. And then the other big change that we made is in RTM and CU1, we supported a maximum of 50 databases per Enterprise Edition server, and that's 50 mounted databases, so that could be active or passive. And in CU2, we upped that up to 100 databases per server as well. So that will change your sizing exercise. Generally, if you've already gone through the sizing exercise, the fact that we've increased that number should result in a reduction in server count for you. Now, IOPS requirements. So obviously, as in previous versions of Exchange, we have reduced our IOPS again. So generally, overall, it's about 33% reduction, and that reduction affects all instances of ESE. So that would be all of your mailbox databases, and your transport queues will benefit from it as well. Now, we say about 33% compared to 2010, but that is the overall footprint. So that also includes things like content indexing and so forth. If you were to actually just compare, say, for instance, database copy IOPS in 2013 with database copy IOPS in 2010, the actual reduction would be much higher, anywhere from 49 to 74%, depending on if you're a cache mode or online mode client. Now, one of the other changes that we've made is around checkpoint depth. So this will make sizing easier as well. The checkpoint depth for all databases is now 100 megabytes. In 2010, we had 100 megabytes for the active copy, but we only had a 5 megabyte checkpoint depth for the passive copy. And so that meant we were constantly flushing the passive copy a lot more frequently and going to disk and incurring more disk I/O. Well, as a result of a lot of the architectural changes we made, we were able to increase the checkpoint depth for the passive copies up to 100 megabytes without suffering from losing our ability to do fast failover. So we still retain that fast failover. And in fact, as a result of the work we did, failover, believe it or not, in 2013 is twice as fast as it was in 2010. We see that in our own environments. In an environment in 2010 where we saw failover taking about 20 seconds on a database level, we now see the equivalent on 2013 taking about 10 seconds. So even though we've done all this work, we're still able to get much faster failover. So storage bandwidth, this is different from capacity. So it really depends on what storage subsystem you're using. Obviously, if you're using direct attached storage in a JBOD configuration, that storage is very close to the server enclosure, physically connected to it in many cases, and so you don't really have too many bandwidth issues to be concerned with. But if you are using some storage solutions that are sensitive to bandwidth, or maybe they're iSCSI based, then they may have some additional challenges that can pose to you. One of the biggest challenges we see is around a process in Exchange called background database maintenance. And this is the system going into the database and doing cleanup and garbage collection and getting rid of stale pages, and in some cases zeroing out pages depending on how it's configured and so forth. And basically on some storage system, that background database maintenance ended up choking out the storage system and required special tuning in some cases. So one of the things that we've done in 2013 is we've actually throttled that back. Now, it says here it's 1 megabyte per second per copy. In 2010, the way we described it was 5 megabytes per second per copy, but it's actually not a reduction in megabytes. What we really actually did in code is we went in and we put in a 20-second sleep timer in between each of the intervals. So that basically, because it's 20 seconds, that's 1/5 of 100, so now we're at basically 1/5 of the activity that we used to do. So that's how we get away with 1 megabyte per second, is because we've got that little delay that's in there. It's not less data that we're actually managing, we're just doing it less frequently now. And as a result of throttling that back, that actually has alleviated the overwhelming majority of problems that we saw with storage subsystems that were having issues with BDM in the pre-validation and the jet stress testing phase. Now, transport storage requirements. We already talked about the fact that the capacity requirements now include safety net. And this is, again, different from transport dumpster. Remember, transport dumpster was really only there to protect you against that lossy failover. So transport dumpster really only collected messages from mailboxes that were in a DAG. If you had standalone mailboxes, transport dumpster did nothing for you. The other challenge with transport dumpster is, in addition to being time-based, in other words, I could keep messages in there for 7 days, 14 days, and so forth, it was also size-based. So you had a maximum limit to how big that queue could grow. By default, if you didn't touch it, it was 18 megabytes per queue. And so 18 megabytes is actually small. You could have that queue filled with 7 days worth of mail, and then a huge message comes in, and next thing you know, knocks a bunch of stuff out of that queue. And that makes it unrecoverable because it's not in the dumpster anymore, so it can't be brought back that way. Safety net is different. Safety net is only time-based. There is no size limit for safety net. And you get to decide how big or how long you want safety net to retain messages. Again, by default, it's 2 days, but you can change that to 0 days if you don't want to use safety net. Wouldn't recommend it, but you can do that. Or you can change it to something much longer, 7 days, 14 days, whatever you want, however far back you think you need to go. Keep in mind, though, that because it's not size-bound, it's going to collect all of those messages from all of those days, and they're going to be in safety net in case you need them, but that will have implications for capacity planning on your transport servers. The other thing is the transport IOPS themselves, again, they're reduced as a result of the IOP reduction we did overall inside of ESC. So it wasn't just things that we did to the store, we did a lot of work in the underlying ESC engine as well. ESC is a fully owned component inside of Exchange, so the Exchange team largely has discretion to get ESC to do whatever we need it to do to optimize for the next product. So because the transport queues are ESC based, they also benefit from all the IOPS reductions that we've done. So you'll see a nice reduction there as well, but you're still going to want to monitor your transport queues to make sure that they are performing up to your needs. So by default, the transport queues are going to be located in that install path wherever you deploy Exchange, and depending on your messaging activity, that might work just fine for you. But if you find that you have very active queues, or if you're sustaining very large queues because of the volume of mail, then you may want to take that opportunity to take the transport queue and move it off to a faster drive to get better performance. Now, I mentioned some statistics around message size. What we see in our own production environments, inside the MSIT environment, we see that in general, we do see about an average message size of 75K, but of course, most of those users are outside the Exchange team. A lot of the heavier users of messaging inside of Microsoft are the Exchange product groups, and we're typically the ones that have the largest mailboxes as well. But what we typically see is that a typical 75K message is about 1 database I/O per second. And that's a pretty good factor for you to use for your own sizing guidelines. And that is, again, one of the reasons that collecting that average message size is so important for your sizing exercise. Now, processor requirements. Just as memory has gone up, our processor requirements have gone up as well. Not just because we've combined the roles and created multi-role, but also because of all of the new work that is happening in Exchange. Again, managed availability, new search technology, workload management, all of these new integration features that we have with SharePoint and Link and so forth, and everything else that's going on now in Exchange 2013 means that you have a bit higher CPU requirements than you had before with 2010 and earlier versions. So keep that in mind. This is a very good chart that will help you understand the kind of requirements that you'll have based on your configuration and your daily message activity. I do want to point out, though, that as you are looking at the data that we're giving you for Exchange 2013, Of course, there's going to be a natural tendency to want to compare that data with the same metrics from Exchange 2010. But you cannot really directly do that. We use a completely different baseline, different hardware, different processor, different spec int, different everything for Exchange 2013. So you can't really compare them apples to apples. It's really more of an apples to oranges type thing. So keep that in mind when you're looking at these charts and wondering why the numbers are so different from Exchange 2010. Now, hyperthreading. How many of you know what hyperthreading is? Symmetrical multi-processing. Okay, great. So those of you who know what that is, or those of you who don't know what it is, it's an Intel-based technology that basically allows the system to act as if there are twice as many processors, twice as many cores that are actually in the system. So from an Exchange perspective, our guidance is to turn off hyperthreading. Okay? Now, typically that's our guidance for a physical deployment. If you're doing a virtualized deployment and you want hyperthreading to be on the hypervisor host, that's fine, you can do that. But if you're doing a physical deployment, turn off hyperthreading on your physical servers. And you may even decide to turn it off on your hypervisor machines as well, because generally the way hyperthreading works is it's not a guaranteed CPU boost. One time you might get a 20% increase in CPU as a result of that technology, but another time you might only get 3% or 5%. So because it's not a guaranteed thing, it's nothing that we can really use as part of a sizing exercise. So we say completely turn it off. And if you do turn it on, size Exchange as if it were off. Okay, don't size Exchange with hyperthreading turned on. Let's say you've got it turned on, you've really got 16 cores in the box, but you turn it on, and now it looks like you've got 32 cores in the box. You need to size as if you actually have 16, because really that's all you have. Hyperthreading cannot actually make CPU magically appear out of thin air, despite the way it may look. So we did a lot of testing with hyperthreading. We found that the performance gains really just were not worth it in terms of what you could reliably get out of it. We could never get a reliable number that we could really base a good sizing exercise on. So our recommendation, again, is to turn it off. But I'll tell you what really surprised us when we were doing the testing is the effect that hyperthreading had on a lot of the processes, and in particular, the memory footprint of those processes as well. So here's why that is. Many of you probably know that we're a managed code application. We need the .NET framework to do that. And the excessive memory consumption that we see with hyperthreading turned on is directly related to the way the .NET framework allocates memory and then works through and deallocates that memory as part of its garbage collection process. So when you think about .NET and the way it works with allocating memory and deallocating memory in the garbage collection process, it looks at two different profiles. It's looking at either a workstation process or a server process. Now, as you might imagine, an application like Exchange, most of our processes are going to fall in the server process category for .NET. And so what that means is when .NET goes to allocate memory, it's actually allocating a lot more memory than it's needed. A workstation process can use a common heap. Heap is the term for the memory or how .NET allocates the memory. It allocates it in heaps. It's just a large memory blob. But in the workstation world, they share a common heap, and so you don't have as much memory, and the garbage collection process is much nicer. In the server world, though, there is one separate heap for each process, and that heap is actually generated as soon as that process is instantiated. So even before the process has done any work, .NET has already allocated a huge chunk of memory to it. Okay, so what we've actually tried to do in code is we've tried to take some of our server processes and, where possible, recategorize them in terms of .NET as workstation processes. So we are able to get some cleanup there. But remember, the way that .NET allocates memory in the server class is it's based on per proc. Okay, so if you've got hyperthreading turned on, you're telling the system that you've got twice as many processors that are actually in there. And so when .NET looks at that number and says, oh, you've got 32, not 16, it's actually going to be allocating twice the amount of memory than if you had hyperthreading turned off. So leave hyperthreading turned off, because otherwise it'll cause .NET to allocate way too much memory for other processors. The other thing you need to worry about with .NET is there is a hotfix out there that all of you should get and put it on your mailbox servers because it directly affects the store memory footprint. And unfortunately, these are not generally available hotfixes. You do need to call and get these. They aren't GA yet, but you can go to the KBs and read about it. Then you can request it and have the hotfix sent to you. When you put this hotfix on your system, you will see an immediate drop in the amount of memory that is being used by the store and its worker processes in particular. And we're talking a significant drop. In some cases, hundreds and hundreds of megabytes of memory getting freed up as a result of this hotfix. And then you deploy the hotfix, and then there's a registry entry that you need to add as well for the hotfix to work. And when you do that, .NET uses a lot less memory for the store process, which is all managed code now in Exchange 2013. And since we're talking about memory, now's a good time to mention that the memory requirements for Exchange 2013 are significantly higher than what we had before. Again, in large part because of some new technologies that we've introduced. And of course, again, as a result of the combining and consolidating and reducing the number of server roles that we have. So the cache requirements, as you can see from this table, they are pretty much fixed from Exchange 2010. That doesn't change. And you still are going to be sizing these mailbox roles based on your mailbox profile, so based on the cache usage. But just keep in mind, though, that the cache management that we do now, again, is different from what we've done previously. It's not dynamic anymore. It's a fixed amount of memory. Ends up being about 25% of overall RAM, gets distributed across all of your active and passive databases. Active databases get what we call 100% of max cache target. They'll get their full database cache on instantiation. Passive databases get 20% of their max cache target, so they'll only get about 20% of their memory needs as they're operating as a passive database. But when they transition from a passive to an active database, then they'll get the full 100% of the cache and the full amount of memory. But that memory for passives is allocated ahead of time at startup, so it's always there. Now, in terms of multi-role servers, they will require additional memory because the legacy CAS is now in there. Now, I'm not going to walk you through all these calculations because all of these calculations, all these formulas that you're going to see on these slides, they've all been encoded into the server role calculator. So you don't really need to worry about doing these calculations by hand. You can if you want, but I can tell you, having talked with several people who've done that now, it's an extremely painful experience to do that. So just use the calculator when you're calculating that. And of course, the minimum amount of memory, you still have to have a minimum amount, and that minimum amount for your users is going to be directly related on their profile and the amount of database cache that they need to get work done. Now, there's also some new networking requirements as well. Now that we've got a multi-role server, now that more and more companies are deploying DAGs and so forth and going with JBOD and having receipts that they have to do, a lot of companies are now starting to standardize on 10 gigabit Ethernet. Has anyone done that yet on their company? All right. Anybody still on 1 gigabit Ethernet? Anybody not on 1 gigabit yet? Anybody lower than 1 gigabit? Any hands? No one wants to admit it? It's okay. I wouldn't either. But generally, you want to avoid the bottlenecks that can be associated by these unplanned things. So, for instance, the need to do a lot of mailbox moves would be one of those, or the need to do database receipts, particularly if you're going over a WAN in a JBOD environment and so forth. So you need to plan for that as well. Generally, we have sort of relaxed our networking requirements, particularly around DAG members. For 2010, we were always recommending 2 separate networks, one MAPI and one replication. In 2013, we're actually taking the opposite approach, and we're starting to say it's okay to deploy with a single network card in all of your DAG members. Just make sure it's 1 gigabit or higher so that you've got the bandwidth to do receipts along with the client traffic that will be sharing that network as well. And then unified messaging. How many of you are using UM? All right, a few of you. So UM also needs to be sized just like the mailbox role and just like CAS. It needs to be sized on a concurrency basis. Now, typically, the numbers that we have are pretty good. We've done a lot of testing and a lot of validation in both physical and virtual environments. And generally, it's about 100 concurrent calls per server with the average deployment. Yes, you could deploy a much larger server, but you're going to run into memory configurations that will be less cost-effective in going down that route. Now, there's also a feature called voicemail transcription, and voicemail transcription is there to basically take the speech and turn it into text and pass it as part of the voicemail along with the recorded file as well. That is a very heavy consumer of CPU usage, and in fact, we will automatically skip doing voicemail transcription if we are CPU constrained at the time that we need to do that. But if we're not CPU constrained, then voice transcription will occur, but it will be a CPU intensive operation. So if you are planning on using that, you'll need to account for that in your sizing exercise. It's about one CPU core per transcription. So that would be one voicemail, maybe an average of 60 to 75 seconds. That's going to be using one entire CPU core to do that transcription. And then the CAS role. The CAS role is very different as well. It has the same name, and we actually, believe it or not, struggled about whether or not we should give it the same name because it is so different. But we understood that a lot of customers know what a client access server is. It might be doing different functionality, but they know it as the endpoint to which clients connect to get into their mailbox. So ultimately, we did decide to keep the same name. Now, what's interesting about this is because its footprint, its resource usage is so low, that makes it an excellent candidate for combining with Mailbox, and hence the reason for going multi-role. And it's basically it is a new role, and so if you are combining it with the Mailbox, you've actually got all 4 legacy internal roles plus a new role on top of it. So that is some extra performance needs that you'll have to deal with around CPU and memory as well, but really nothing around disk because CAS is completely stateless from an Exchange perspective. There are some beefier processor requirements, but it's not quite as bad as it was in Exchange 2010. Exchange 2010, we were looking at a 3-to-4 ratio, CAS cores to Mailbox cores. Now we've got about 25% of that down, so we're looking at a 1-to-4 ratio now. Now again, multi-role will change that because you've got it all in the same box, so you're just going to size for the multi-role configuration itself. In terms of CAS memory, CAS does have some memory requirements, but we've really narrowed it down to a very simple formula. It's just a baseline of 2 gigabytes, and then for every core that you have in the system, an additional 2 gigabytes of memory. That is the easiest server role to size in Exchange that we've had in years. It's a super simple formula, makes it very easy to scale that server up and also to scale it out economically as well. So, we've talked a lot about multi-role and why you should do it. There's a couple things to think about why you might not want to go multi-role as well. But there's very few deployments. Most deployments should be multi-role. But you can get, for instance, maybe increased availability at the CAS level by separating things out. That may or may not be a concern to you, depending on your configuration. There still are some issues around Windows Network load balancing, both in terms of scalability and in terms of its lack of service awareness. But again, if you wanted to use network load balancing and you're also deploying a database availability group, then you can't go multi-role. You'd have to split them out to do that. And then the way in which we manage certificates has also changed as well, and this might be a concern for you because you no longer need to deal with certificates on the Mailbox role. On the Mailbox role, we will always and only use self-signed certificates, and it's only the CAS role that requires an actual trusted cert. So that would be a public cert or some internal PKI solution. But either way, the fact that you are now in a multi-role environment, that could make things a little challenging and complicated for you around certificate management, because we really don't want you to touch certs on the Mailbox server at all. And the last server role, Active Directory requirements. Now, I talked about this morning about the upgrade process and how our Active Directory baseline requirements have not changed in several years. We still need just Windows Server 2003 SP2 or later. We would prefer 64-bit directory servers, but we don't require them. We do assume them, though, in the calculations that we do inside the calculator. So if you are running 32-bit directory servers, you might want to look at maybe upgrading some of those to 64-bit. And generally with Active Directory, our best practice guidance is to just give it enough memory so that it can hold the NT database, the DIT file, in memory and not have to go to disk for anything. So if you've got a large number of objects and a very large DIT file, you need enough memory to hold that in memory while you're running. That will give you the best performance from not just an AD standpoint, but also from an Exchange standpoint as well. All right, let's talk about the role requirements calculator. I'm going to show it to you in a little bit, but I wanted to give you some background. And basically, what we've done is we've encoded all of our guidance around sizing and capacity planning and everything around memory, CPU, disk, and network, the 4 food groups, if you will. We have taken that and encoded it into the calculator and basically turned the calculator into a modeling tool and into a deployment tool with some of the scripts that we can do now. And that allows you to do a whole bunch of things, try out different failure scenarios, figure out what is best for your organization in terms of your business requirements, figure out what your failure domains are and how to architect reasonably around them for high availability purposes and so forth. And then, of course, we've done other things like added the ability to have scripts and some other new features around CAS sizing, transport sizing, high availability recommendations, storage recommendations, and so forth. So it really is quite a different tool from what we've had previously. And I don't mind saying, quite frankly, that was one of the reasons it took us so long to release the new calculator tool. It's just so much more complex than what we had before. Plus, we had to account for all of the architectural changes in the product and basically re-encode all of our new guidance in doing so. Okay, so let's switch over here, and I'm going to just show you the calculator real quick. How many of you have actually seen the calculator before for 2013? Great, a fair number of you. Okay, so for those of you who haven't seen it, let me go up to the top here and just zoom in on it. As you can see, what makes it really super easy, whoops, I hate that drawing when I do that. What makes it really super easy is the fact that it's an Excel spreadsheet. So I can move around in here. I can see all the stuff on Excel. If I have Excel 2013, that's all I need to use this calculator tool. So if I go down here, scroll down to where we actually have the information that you would enter here, you would basically, there's 2 things that you need to do. You'll notice that some of these things are in blue, and some of these things are in red. Go back up. There we go. Okay, so you see these red things? These are drop-downs. You choose the appropriate selection from the drop-down. The things that are blue, those are values that you need to input yourself, and those will be very often unique to your own organization. One other thing I'll point out is you see these little red corner things. These are comments. And these comments tell you exactly what we expect you to put in there. And sometimes we give you a little bit of extra information about why we need that in there or how it affects the sizing process as well. So the types of information that you would enter in here are things like, what's your global catalog server architecture? Is it 64-bit or are you using 32-bit? Is your server role going to be multi-role or single role? Are you virtualizing, yes or no? Are you using high availability? What's the number of mailbox servers that you think you need, or the number of database availability groups that you're going to deploy? And if you are deploying database availability groups, are you deploying lagged copies as well? And are you deploying in a site resilience configuration? That's also a new feature that we've added to the calculator. So if you are deploying a DAG across multiple AD sites, the calculator can now help you lay out your database copies and figure out what your network bandwidth needs for that are as well. So the calculator does look complicated. It's got all these tabs that you can see down here at the bottom, input, role requirements, scenarios, and so forth. But it's really just the input tab that you need to go in and add this information in here. So some of the information that we've talked about is that user profile information. You know, what's the number of messages that they send and receive each day, and what is the average size of those messages. So you would plug those values in here. Whoops. See, now when I try to write on it, it doesn't want to do that. So you would plug those values in. Wow, it really doesn't want to do it. It probably will do it if I do it the wrong way, like I did before. Yeah, no, it doesn't. Oh, now that will write. Okay, anyway, you can see you plug the values in down here. And we have options for you to do multiple tiers of mailboxes. So here, this is a tier 1 mailbox. We might have, say for instance, this has 100,000 mailboxes listed. Maybe we're just going to have 10,000 tier 1 mailboxes. And we can say that their profile is sending, let's just say 150 messages a day. The average size of 75K is usually a good one to use if you're not exactly sure what it is, although do try to figure out what that is in your own environments because it is important. What mailbox size limits do you want to give them? Here, by default, we've got a 10 gig mailbox. We might want to give them a 5 gig, a 10 gig, a 15 gig, 25 gig, 100 gig in some cases, because we actually do testing regularly with 100 gig mailboxes. The next one is whether or not you're archiving. Let's move this up this way here. And if you are archiving, you'd say yes to that and decide how much of a mailbox you're going to give them. What's your deleted item retention window, because that will have a capacity impact. What is your tier 2 for a next tier? What is your backup configuration? By default, we assume you're going to use Exchange native data protection, which basically means you're using the DAG, you're using single item recovery, you're using other features, and you're basically not taking normal traditional VSS backups. So if you're using Exchange native data protection, then you don't need to worry about your backup frequency. In terms of storage options, are you using JBOD? Are you using RAID? What size disks are you buying? What type of disks are you buying? So for instance, you can see some of the choices that you have available here. They're either going to be 7,200, 10,000, or 15,000 RPM. We do include the 10,000 and 15,000 RPM disks in here because we know some customers already have purchased them and they want to leverage them for their environments. But if you are going to buy new storage for Exchange today, there is really no reason whatsoever to buy a 10,000 or 15,000 RPM drive, considering that we have specifically optimized Exchange 2013 for the 7,200 RPM SATA and SAS drives. There's no reason to overspend on your disks, but we do include those options in the calculator in case you've already bought those disks and you want to use them for your deployments. Then we get to the server configuration, and again, we allow you to specify your primary data center mailboxes and your DR or secondary data center mailboxes if you're doing site resilience. Here's log generation info. If we move over to the other side, we can choose the type of networking that we have. So obviously, gigabit Ethernet is one of the choices here, but there's other choices like the variants of OC, 10 gigabit Ethernet, and a couple other variants of gigabit Ethernet as well. We also allow you to plug in your network latency. That's particularly important because we do have support boundaries around network latency and DAG members. And of course, you want to be aware of network latency just from a client experience standpoint as well. So basically what you do is you plug all the values into the calculator, into this input page, and once you've got them in there, then it starts to spit out all of this other information, like it gives you your role requirements. So we know what we need for each data center in the role. We can see the activation scenarios once we have that information filled in, so we could see what would happen in different failure scenarios. We can look at distribution. So the distribution not only allows us to execute these scripts, but it also lets us simulate failovers and failure scenarios as well, so that we can see before we actually do any of the deployment what the system configuration would look like if we had one server fail, or if we had two servers fail, or if we had a server fail in each site, if you're doing multi-site, and so forth. And then you've got all these buttons here for exporting scripts. So export the DB mount list, the DAG list, the primary database, the role calculator scripts. And basically what this will do is it will just create PS1 files, PowerShell files, anywhere you want in the file system. And then you would use those scripts to do the actual deployment of your DAG and your mailbox databases in the place where the calculator thought you should deploy them. And again, because all the scripts are in there, it is basically your documentation as well for the actual deployment configuration. It's your baseline, it's a reference, it's something that you keep and you preserve for historical reasons. And then again, you've got these buttons here, so when you see all these database layout here. You can see how it's laid out my copies. I could go ahead and touch one of these buttons and fail a server, and you can see now in this middle one that I failed, these copies have now moved to another one. And then I could just hit a button and recover the server back and put the databases back where they were. If only the actual DAG were that easy to do that, huh? And of course, because this is a site resilience configuration as well, you can also fail the entire WAN, which would cause all of the databases to fail over to one site and become active there as well. And then you can recover the WAN and see how things would rebalance themselves as well. Okay. So that is the server role requirements calculator. We strongly recommend that you always use the latest version. The latest version as of today is version 5.9, but we do periodically release updates. Anytime we do an update, we will blog about it on the Exchange Team blog, and then that same time we will also simultaneously post the update to the gallery on TechNet where you can download this from. It does require Excel 2013, so if you're using previous versions of Excel, you'll have to try to get 2013 somehow to use this. But other than that, it's a very simple and easy thing to use, and I think all the information that you need to be concerned with is already largely taken care of for you. You just have to fill in the numbers for your unique environment. All right. So just a couple other tools and resources. Again, the Exchange Team blog is a great place to go. It's typically the first place that we publish new technical information. Now, sometimes TechNet gets it first, but when we've got critical information like this Ask the Perf Guy blog that the Perf PM did, that's something that we wanted to get out fast, and so we published it on the Team blog. If you're not familiar with the Exchange Team blog, it is authoritative. It is official. It is the product group's actual blog. I'm one of the blog owners. There's a couple other blog owners that I work with, and it is authoritative. So if you read something on the blog, it's just as good as reading it on TechNet or hearing it in one of these sessions. It is official and authoritative. So consider that also a viable source for information. Now, I mentioned earlier that the baseline that we're using for our performance guidance and the sizing guidance and the calculations that are done inside the calculator is different from the baseline that we used in Exchange 2010. And so you may need to use the processor query tool to sort of reconcile the differences between the processor performance characteristics that you have and the processor performance characteristics that are listed on this website. So this will give you the specific value that you need to put into the calculator based on the processors that you believe are going to be in the servers that you purchase to run Exchange. So that's where you get that information. And then there's also our jet stress tool. Once you've done the sizing exercise and you've built up the system, prior to going into production, we always like to have you validate the storage subsystem, and that is what jet stress is designed to do. Now, can anybody think of another tool that's also used for pre-production validation? Just raise your hand or just shout it out if you know it. No, the best practices analyzer is actually gone in Exchange 2013. Or I should say, as of RTM CU1 and CU2, it does not exist. I will say that way. But can you think of another tool that might be useful for pre-production deployment? Maybe testing the client load, for example, if that helps?
I don't remember the name, but there's a Mailstorm tool which sends...
Nope, it's not Mailstorm. Nope, it's not XRCA. LoadSim, close, getting close. LoadGen, that's right, load generator. So load generator is coming out. I can't give you an exact date, but we are working on it, and we do have plans to release one later on this year. Can't tell you exactly when, but it is under development and coming soon. But jet stress is there today. You can use it both in physical and virtual environments, and we also have now moved to version 4.0 of our Exchange Solution Reviewed program. How many of you have heard of ESRP? Okay, just a couple of you. So ESRP is a partnership program that Exchange runs with storage vendors, and basically the storage vendors come in and they deploy Exchange on their storage solution, and the storage and performance team goes and we validate that their storage solution works as advertised, provides the IOPS that Exchange needs, and basically validate it across the stack from a functional and performance standpoint. And once we validated them, then we list those vendors and their specific solutions on TechNet in the ESRP page. So we've spun up the program. We don't have any TechNet content yet, but as soon as vendors go through that program for Exchange 2013, we'll start having them listed there. And that gives you the benefit of being able to go to a website and see solutions that we've already validated for you. So you know if you go and buy that solution from the storage vendor that you will get exactly what you expect to get out of it in terms of Exchange performance. All right, so with that, I think I've got about 2.5 minutes left. Appreciate you guys staying so late tonight for TechEd After Dark. Don't forget to complete your evals. You can win a mouse. Or even better, come to the Microsoft Office Showcase, scan your badge, and win a possible flight with one of our very valued MVPs that we have here. Yoni has his pilot's license and a plane ready to go, so you might be one of the folks to go up in the air with him this week. And then, of course, there's some great resources. We want you to go ahead and download Exchange and Link if you haven't already, and then, of course, all the other related content as well. So I'm happy to entertain some questions. I know it's late and you guys probably want to get out of here, but I'm happy to stay as long as you want to answer questions, since there is no session after this, so there's no pressure to get off the stage. So I will again remind you to fill out your evals, and with that, I'm happy to take questions. Yes, sir.
How many databases do you have in standard edition 2013 and enterprise?
Yes, in the standard edition of 2013, you can have a maximum of 5 databases. And when we say databases, we mean any databases that are mounted, so that could be an active database or a passive database. Yes, active databases are mounted and attached to the store. Passive databases are mounted and attached to the replication process.